Okay, I want to create an example of building a proxy for Solidity deployment on any kind of EVM compatible blockchain. Um, I'm using this Foundry Forge Docker file that I use for all my smart contract development. And I have another video that describes this and how to set this up. So basically, I'm just going to forge init a new project. And that should give me dubious ownership. All right. So once I finally get past all of the nanny messages, it should have a simple project here, and we should be able to forge build. Okay, and there's actually quite a few dependencies already. And let's also, I'm going to use the Open Zeppelin contract, so let's install that. Make sure I spell it right. And to make your contracts upgradable, you don't need to use the Open Zeppelin upgradable package. That's to make the Open Zeppelin contracts up to upgradable. I'll show you how to implement this proxy without using the Open Zeppelin upgradable contracts. And you can just make the design choice at some future time whether or not you want Open Zeppelin to be upgradable. Okay, so now we have some simple example contract, and here I'm actually just gonna let's install Solidity so we get nice pretty colors. All right. The purpose of an upgradable contract is to allow you to manage your source code over time. You make software changes and you can allow those to be reflected in a specific location, which is going to be the proxy. And the proxy will just upgrade and point to the new location. And over time, you can continue to upgrade the project. The downside of this is that over time, you're going to lose access to being able to init and re-init your project. It's going to become cumbersome with managing constructors and changing the state of your contract. So it really increases the complexity, and also the constructor is supported by the Solidity language, so it's enforced by the Solidity compiler. So if we do any other kind of contract initialization, it's going to not necessarily be enforced by Solidity, so it, immediately becomes accident prone and dangerous. So we should actually take on this idea of building an upgradable or a proxied contract very seriously, and only do it in the cases where the contracts really warrant that behavior. And if it was something like this, which is just like a simple counter or something, it probably doesn't actually make sense that it would be upgradable. So let's start by creating a constructor for this. And then let's just fix the test. So rather than set number, all right. Now we should be able to run forge test and see if it works. We're still referencing that one here. I don't use it anymore, so I'm going to get rid of it. And let's further specify that we want this to be immutable, which is a feature of Solidity. Now this will remove this behavior. But if we just wanted like a simple getter, okay, so this kind of becomes like a number fly weight. Okay, so we'll just call it count fly. And let's see if it actually still works. One more reference here. Okay. All right, finally refactored our code, and I'm expecting the test to pass. All right, great. So this is what I would consider to be, like a well-designed number fly weight. It's immutable. It has a nice constructor to initialize it. It's essentially properly set up. But what are we going to have to do to make it initializable? So the challenge is going to be, we can no longer use the constructor when we're implementing our proxy. And that's a major issue, actually. What I want to do is I want to modify this so it no longer has a constructor. Now I can use the OpenZeppelin utility called initializable. And what this allows me to do is this allows me to make my contract have an initializer method so that I can kind of treat it like a constructor and make it run only one time. And then we will use, when we're using proxies, one instance of the constructor. So we want to actually turn that off. Let's see if we can get this to work. So I think I'm missing a remapping for this. So we want OpenZeppelin to be equal to lib OpenZeppelin contracts/contracts. Let me see if that fixes it. Oh, there's one too many contracts. Let's try again. All right, good. So we got our Open Zeppelin dependency working. Let's make that an initializer. Now, all right. So sorry if that confused you. Just have to get that mapping working. Now there's a problem here because now this can no longer be immutable because number is only allowed to be set immutable by the constructor. So this is one thing. So, we're essentially losing features of the language by implementing this proxy and making it initializable. Not only have we lost the constructor, which is a very important feature of the language, we've now kind of lost the ability to specify something as immutable in the constructor. So those are pretty useful things. It's useful from a security standpoint. It's useful from a programmatic standpoint in terms of knowing that, we never meant to change this value. And if we're going to re-implement those features of Solidity, we're going to have to bend over backwards in order to be able to do it. And your average, developer is probably not going to take that effort. And in all honesty, probably, considering this code that's going to add to your contract and space considerations and performance considerations, for the most part, it's probably not going to be worth it. So we're simply just, by implementing a proxy, we're losing some of these important features. And that's why it should be considered, as to whether or not you actually need to do this and, how much it benefits you. All right, so here, let's try and build it one more time. Okay, so now I was using the constructor here, so I have to change this. And what I frequently like to do is, instead of providing a constructor, because now I'm going to be implementing this proxy style mechanism, I want to be able to implement some sort of a factory. So let's get on and talk about the factory, because this fly is pretty much where we want it to be. So let's create another contract. And I apologize, it's getting dark here and rainy, and you can probably hear the rain beating down in the background. This is spring in Illinois. It's what it sounds like. Let's go ahead and implement our counter proxy. All right, so I'm going to use the Open Zeppelin ERC-1967 proxy, and I'm just going to copy and paste that in because it's a lot of typing. So let's create an implementation of this proxy. And the way that we're going to do that is just to provide a constructor. The constructor is going to need two different things. So it's going to need the implementation. So this is going to be the actual code that's going to get delegated whenever we call the proxy. And then it needs any arguments. And recalling, our counter, the argument was a number. So let's just go ahead and implement that. Okay, and then what I want to do is basically, the reason I provide this proxy implementation is you have to actually encode the way of calling the calling convention through the ABI to the proxy. So I'm just going to go ahead and build that into this constructor so that future users of this contract don't have to understand that calling convention. So here's how we initialize it. And then we're going to encode the ABI. So we want it to be able to import count fly from counter. Okay. And recall that we created initialize, and it had one argument, which is that number. Okay. And so now actually we've created the proxy. And so we could actually, simply call this as if it was the count fly. But I usually like to create a factory method as well, just because it simplifies the whole construction process a little bit for the user or for the caller. So the first thing we need to do is create our implementation instance. So that's going to be just the inert code that gets referenced by the proxy. Then we need to create the proxy itself. Passing those arguments that we want to pass to the initialization phase. And then what we want to do, and rather than returning an address, I'm actually going to return a count fly here. So what I'm going to do is return the proxy as if it was an instance of this count fly. So now we should be able to reproduce our original test using these functions to behave the way it did previously using the proxies. And now we'll just update this to use the factory method instead. And so this will return the proxy, and we expect the proxy to have the same behavior as the previous implementation. Okay, and it does. But a proxy is fairly useless unless you actually can upgrade it. And so let's think about what we need to do to upgrade. Now, typically what I do is I provide a separate method to upgrade my upgradable contract. And so this initialize is now, because of this initializer modifier, this requires it to be called only once. But if my goal is to upgrade this class over time, this contract, and, understanding, that in a real world scenario, you're going to have a much more complicated style All right, sorry about that interruption. I just had a little alarm go off, but it wasn't anything. So anyway, I was implementing this upgrade method. And in the language of Open Zeppelin initializable, that's a reinitializer. And what this allows you to do is specify a version for the upgrade that's going to allow you over time to upgrade this method and prevent upgrading only when the version would reduce the previous version. All right, so I want to implement an upgrade method on the proxy to allow me to upgrade over time. So how would I do that? So I'm going to upgrade to a certain number. And what I need to do is to call the implementation of the upgrade method that I just created. Now, this is going to result in a couple of additional requirements or responsibilities. So let's explore that. So the first thing is I need to create a new implementation. So let's implement a way to handle the version and, probably you want to do something a little bit more sophisticated than this, but this is what I'm going to do for right now. So that as my software changes, I can update this version number and the proxy will be satisfied. And now I have an ERC-1967 proxy. So the question is, how do you actually upgrade it? So the way to do that is you do this upgrade call, upgrade to and call UUPS. So what is UUPS? So first of all, we're going to need a new implementation fly, right? Because this is going to be the new version of the code that's going to be delegated when we get calls. And then we're going to need to encode something to call on it, just like we did before. But remember, the selector is now going to be called upgrade. Right, and the argument is still number. And then we can pass this force call argument. It's generally safe to let that be false. So this just tells it whether it should always call it. In this case, it should get called. So we can, through our test, decide if that's necessary. Then the other thing that I need to introduce here is I've called it this UUPS. So I want to upgrade. But what I want to do is, rather than have the proxy decide whether or not the upgrade is allowed, I want the contract itself, its code, to be able to decide if the upgrade is allowed. So let me grab this additional utility from OpenZeppelin, UUPS Upgradeable. And let's make sure our account fly is UUPS upgradable. So this means that it's going to implement a way to communicate to the proxy that it should be allowed to upgrade. And there's a variety of policies that people could implement. So this is how you do it. Authorize upgrade. And who wants to upgrade it? The caller. And when that is done, let's go ahead and have an event for that. So in this case, I haven't implemented any logic in terms of, whether or not the upgrade should be authorized. This just gives you the chance to revert if it's not authorized. For this case, there's not really any kind of clean way to decide, if that caller should be allowed. I could, do something just for test purposes. But for now, suffice it to say, since this is not going to revert, then my upgrade should be allowed. And recall here that in the upgrade, there was an additional argument, and that was going to be the version itself. And we're calling that the implementation version for the upgraded implementation. Okay? So now let's see if we can implement a test using all of this new code. Count proxy, I just was checking what I called it. Okay, and then let's go ahead and call the upgrade method. Okay, so now I'm going to upgrade it with a new version of the code. I'm going to call the reinitializer to reinitialize the state to have a different value. And then I should be able to continue to use my proxy in the way that I was using it before, but I should get these new results. So let's see what happens. Okay. The address must be payable for the proxy, okay? That's what that error indicates. Okay, and so the issue that we ran into is that the contract is already initialized, so it's not allowing us to reinitialize this thing. So what's wrong? Well, was it the version number? So we already initialized it once when we called the initialize method. So let's see if we upgrade it to a higher version, if that helps. Okay, and in fact, it did help. So every time you call this upgrade, the goal is going to be to have a higher version of the code. And then essentially, this is very similar to the original implementation in the example implementation that had a setter and a getter. But the difference is that each time you create one of these flies, that it actually mutates internally the code, allowing the fly itself to sort of have this kind of, I'm going to call it quote unquote simple implementation because it's actually much more complicated than the original implementation. But now we're actually upgrading the code itself so that we can make changes to the logic if there is any logic. And we can also delegate using the UUPS mechanism, the authorization to the code itself for the contract. So we've just achieved a much more useful level of upgradability. Now, we always need to keep, in our mind We always need to keep in mind the fact that we've lost some things. We've lost the immutability of this number value. We've lost the availability of constructors and solidity. So we've done some harm. So it really is a trade-off as to whether or not you get any benefit from implementing proxies. But this is a complete working example. We have the counter. It's initializable, UUPS, upgradable. Excuse me, and you have the proxy itself with a factory method that allows you to create an instance. And the test shows you how easy it is to use. And the interface is much like the interface you would expect from the original implementation. So these are all highly desirable features when you're upgrading contracts.